This video is about mole calculation. The first problem asks you to go from moles of oxygen to grams of oxygen. So we need something that links the moles to gram. That relationship you can use the periodic table to find. If you look at the periodic table, it tells you that 1 mole of oxygen is equal to 15.999 gram. That's a molar mass of oxygen as a single atom. This 1 mole means that it contains 6.02 times 10 to the 23rd atoms of this oxygen. It's referring to that many elements that weighs 15.999. But if you remember, oxygen is a diatomic molecule. So it exists as O2. So 1 mole of oxygen is actually 2 times 15.999 gram. If you carry out the calculation, you'll end up with 31.998 gram. What this means is 1 mole of oxygen molecule, which contains 6.02 times 10 to the 23rd molecule, weighs 31.998 grams. So if you carry out this calculation, you start with what they give you, which is 0.25 moles of oxygen. And you put the unit that you want to get rid of at the bottom of the fraction, which is moles of oxygen. The unit that you want to get to goes to the top. And this is equivalent relationship, so you get it from the periodic table. We already found out that 1 mole of oxygen weighs this much, 31.998. If you carry out the calculation, you will end up with 7.9995 gram. Now the last step is answering in the right number of significant figures. If you count number of significant figures in all these calculations, over here you have 2, over here you have 5. And you always answer your answer in the smallest number of significant figures among all these numbers. So that is 2. You use that to answer, and you give answer as 8.0 gram. And that's 2 significant figures. The next problem asks you to go the other way. So you're going from gram to mole. You follow the same format very systematically. So starting with what they give you, grams of O2. And you want to get to, now I'm going to use different format, which is like sort of like a table. This corner means multiplication, and this is just a fraction. So the unit that you want to get to is moles of O2. Grams of O2 goes on the bottom because we're trying to get rid of this unit. If you look here, we already did that. So then you have the same relationship, 1 mole of oxygen. Now you're putting this on the bottom. If you carry out the calculation, you get 0.0050 moles. This is given in 2 sig fig because you use 0.16 rather than 31.998 to use the sig fig because it has less number of sig fig. If you want to use the scientific notation, the correct answer will be 5.0 times 10 to the negative third moles. The last problem requires you to use Avogadro's number, and you can use any of these relationships. Avogadro's number is sort of like a dozen. When you mention dozen of something, it means 12. So you can refer to dozen of donut as well as dozen of eggs. It can mean multiple different things. It's the same thing here. When you're referring to mole, it means this Avogadro's number, 6.02 times 10 to the 23rd of something that you're referring to. So 1 mole molecule means that this many number of molecules. 1 mole of atom means 6 times O2 times 10 to the 23rd atoms. So if you use that relationship, you start with 0.25 moles of O2, just like how you start out with what they give you. And we'll set up the table again. And you know that 1 mole of oxygen, if you look here, 1 mole of oxygen is 6.02 times 10 to the 23rd molecules. And if you carry out the calculation, you'll end up with 1.5 times 10 to the 23rd molecules. And this needs to be given in 2 sig fig because you need to follow this one rather than the 3 that you have here. So the general trend that you need to see, or it's very systematic, this kind of calculation. You start with what they give you. You put the unit that you want to get to on top. You put the unit that you want to get rid of on the bottom so they cancel out as a fraction. And you multiply out the whole thing. And this is sort of like, if you're putting something as a fraction, it's sort of like an equivalent relationship. So I hope you found this video helpful.